have been directly or indirectly talking about the introduction of the course, the scope of environmental geomechanics, and in the previous lecture I gave you an idea about what are the current trends in environmental geomechanics or the subject as such. And after listing several state of the art topics, I picked up energy geotechnics, which is the need of the hour. Everywhere in the world, the big crisis is how to harness sustainable energy. Go to the western world, 6 months of the year, the entire country remains snowbound, and imagine the amount of energy they required for refrigeration, heating up of their houses and infrastructure and so on. Come to the countries like India, where we have temperate climate, again the energy geotechnics plays a very important role. We have to talk about sustainable energy by which we can cool our infrastructure and the buildings. Alright. So, imagine the parts of Rajasthan and northern India which remain under severe heat conditions, for almost 4 to 5 months. Now, this is where we have talked about what are the resources which can be exploited to generate more energy, and I talked about a discussion on nuclear energy versus thermal energy, and then we discussed about the volume versus concentration concept, and then later on I took that concept to quantify, like how to solve these type of problems or the philosophies by using the concept of THMC, that is thermo-hydro-mechanical chemical coupling. And then this is where I also talked about THMCB, thermo-hydro-mechanical chemical biological coupling, and how these type of couplings can help you in solving the issues which are related to production of energy and particularly the nuclear waste disposal and post disposal monitoring. I will go ahead with this concept of energy geotechnics in today's lecture, and to just give you an idea about what is happening in the contemporary world, and some of you who have already heard about the gas hydrates, I will discuss a bit about what these gas hydrates are. So, I have provided link over here. If you click over the gas hydrates, you will get a lot of information about what is happening in the contemporary world. So, this is a clipping which shows in a first natural gas hydrates discovered in the Indian Ocean. I mean, like, this is the source of energy in the days to come, and people speculate when the fossil fuel is over, this is the source of energy, or this is the type of energy which can be exploited for sustenance of the society. So, it is an interesting report which you should go through. Most of the time these hydrates are available in the offshore regions or in the water bodies, and I will discuss in details about these type of structures in today's lecture in details, and what these structures have to do with the geomechanics. Now, as far as the Indian scenario is concerned, if you go through the current affairs, this is what is happening. So, India might hold world's second largest gas hydrate reservoirs, and this is very good news. The regions which have been identified are the KG basin, Andaman area and northeast. So, KG basin is a very rich area in which the hydrates are deposited. If you talk about the South Asia, gas hydrates as the resources, and this is a very interesting document which is available on the net. This comes from SARC Energy Center, Islamabad, Pakistan, gas hydrate resource potential of the South Asia. Well, whenever you get time, you should go through this. This is how the hydrates looks like. So, if I expose it to the atmosphere, it catches fire because of the methane getting emitted in the environment. So, basically what hydrates are? These are basically ice like clathrates. This is how they look like. So, what you will notice is that this is the molecule of methane. Those of you who love chemistry, there is a carbon attached with 4 hydrogen atoms. So, this is a methane molecule which gets trapped into water, and because of the pressure and temperature condition, it gets trapped over there due to action of very high pressure and low temperatures. We call them as ice like catharates, and truly speaking, this is a state of a material or a geomaterial which also is considered as a multi-phase. Americans would call it as multi-phase. Alright. So, many people are doing research nowadays on multi-phase geometry, multi-phase geomechanics. In conventional geomechanics, if you remember, you have talked about only mostly started with 3 phases, but then very cleverly you brought it down to the 2 stages by saturating all the samples. So, most of the tests which you did in the laboratory were under soaked condition, whether it is CBR, whether it is hydraulic conductivity, whether shear strength, triaxial consolidation, you saturate the sample for enough time so that the air phase gets lost. So, truly speaking, the conventional geomechanics does not capture the real life response of the geomaterials, and keeping this in view, people have started working on unsaturated state of the material. They talk about the 3 phases, and here we are talking about the multi phases. So, the difference is we have solids, we have liquids, and in liquids we have let us say water, we have gases, fluids, alright, a composition of the two, and when you are lowering the temperature and playing with the pressure, the state of fluid may also get changed. Very high pressures would cause dissolution of the gas which is present in the pores of the soil into the liquid phase, alright. Similarly, a very high temperature, low temperature might change a certain fraction of the liquid into a solid phase, say water getting frozen in the pores partially. So, imagine a state of the material where you have soil skeleton, where you have little bit frozen water, you have completely frozen water, where you have no frozen water, and then you have different type of gases. This could be fumes, this could be chemicals, that could be anything, alright, it could be methane gas. So, this is the state of the geomechanics in the 21st century, which people are trying to work on, and these are going to be more realistic. So, whether it is atomic waste disposal which we were discussing the other day, or whether it is hydrates, gas hydrates, these are the good examples of how geomaterials, when they come in contact with different environmental situations, conditions, they behave. In other words, the response of the material when it is exposed to different environmental conditions. Yes, please.
Sir, is this methane trapped in ice like a crystal, or like a crystal, solid crystal in ice?
No, gases cannot be crystallized. So, methane molecule gets trapped into the crystal of water, alright. Okay, any other question? So, I hope you have understood what is the state of the art on the subject. Yes, please, the geomechanics as such. So, suppose if I ask you to find out the compressibility of this type of sediment which is a multi-phase sediment, or what is the hydraulic conductivity of a fluid which is passing through these sediments, or what is the shear strength of these type of sediments, clear? This becomes very complicated. The simple thing would be you go for the reconnaissance. So, the way the geophysicists were finding out the minerals location on the earth, same way you have to go reconnaissance in a ship and find out where these type of reservoirs are. Or sometimes if you check on the net, mid ocean fires, clear, that is an indication that somewhere down below you have a reservoir of hydrates. So, the methane gas is leaking and this catches fire, and in the middle of the sea you will find there is a big fire, alright. So, these are the good indications. There are a lot of people who are working on resources. So, geophysicists, they were talking about location of water table, location of minerals, clear, and now the shift is on finding out hydrates. So, where is the habitat of such type of elements? These are marine environment, this could be lakes, this could be water bodies, and wherever you have sediments. So, each molecule of hydrate would be having 180 meter cube of methane gas, imagine. That means what is happening is, as you were asking, the more and more pressure which I apply on the system, the lower the temperatures, so many molecules of methane gas can be packed inside the matrix, that once you take out this system and put it to the STP, standard temperature pressure condition, you can produce 180 meter cube of the methane gas. Imagine, that would be the most wonderful thing. So, when you fill your car, diesel tank or petroleum tank, what is the capacity of the car diesel tank? They are hardly 27, 28, 30 liters, 50 liters, trucks would be about 200 liters, 500 liters and so on. For an aircraft it would be in thousands of liters, clear. So, imagine one molecule of the hydrate crystal is capable of producing 180 meter cube of methane gas. So, this is what is going to solve the energy crisis of the society, the contemporary world. This is how they look like a cauliflower or a cabbage, you may say. I will show a lot of photographs today. So, what are the different sources of the methane gas? The first thing is, this is the question as you were asking. The second thing is, types of methane gas are two. One is thermogenic, alright. Thermogenic corresponds to the situation which is due to the chemical reaction which are occurring in the earth's crust, alright, thermal processes, because of the temperature gradient of the sediments inside the sea. So, what you are observing here is, I have done an animation that the bubbles are coming out and this gas gets trapped into the sediments, and under under varied conditions of pressure and temperature, they will get trapped over there and they form hydrates. Normally thermogenic gases are methane, C2H6, any idea what it is? Ethane, you are right. So, C2H6 is ethane and C3H8 propane, perfect. So, all these thermogenic gases are methane, propane, ethane, it is a combination. Now, our interest is mostly in the methane gas. So, I can produce the methane gas, I can bring it to the refinery and I can filter out all those things. Normally, this type of process occurs in the deep seas. So, I have drawn a line over here which shows the depth of the water column, alright. So, under deep sea conditions, normally thermogenic processes occur. There is a second situation which is known as biogenic methane gas. So, biogenic methane gas is a pure form of the methane. We will be more interested in biogenic methane, because thermogenic methane would require some sort of a refinery, and microbial decomposition of the organic matter which is present in the sediments is the main cause of biogenic methane production. And I hope now you can realize that why most of geotechnical engineers like us are venturing into the biogeointerface. And what really happens when the sediments are attacked by the biotic activity, microbial activity. So, this is a very interesting idea where people are trying to master, becoming cross disciplinary or interdisciplinary subject, where we have to learn a lot from biotechnologists, microbiologists and so on, and to master the whole thing. So, idea is to trap these type of gases, alright. Now, the whole realm of new or neo environment geomechanics starts, clear. So, sometime back I said that I would be very eager to know how much is the migration of these type of gases in the sediments. So, until now you have been doing only constant head test, falling head test to find out what is the permeability of the water which is seeping through the sediments or the soils. Now, the situation is different, we are talking about gas migration through the sediments, alright. And when gas migrates through the sediments, pressure temperature conditions are peculiar, microbial activity is peculiar. So, this is what has to be studied. Look at the work which is done by my research scholar Dr. Jeevan. He is a faculty member at NIT Trichy right now, and he is the one who has established the entire setup himself, and he has done wonderful work on deriving the gas permeability through saturated soils, unsaturated soils under different environmental conditions. Refer to his papers, alright. So, this is a big challenge, how gas flow occurs rather than only the fluid flow. You are talking about the water migrating through the. Normally, the biogenic methane gases or the sediments are in the continental reef, very close to the onshore, adjacent to the coastal area. So, this is the differentiation between the types of gases which you get. Now, coming back to your question, I can always take a sample and I can do different types of analysis, including carbon dating, to find out what type of carbon is present in what type of sediment. So, this subject now becomes absolutely interdisciplinary, and this is the future of the geotechnical engineering. All right, any other question?
Although sir, biogenic methane is in the purest form, but I think its quantity will be far less than thermogenic form, because of that we don't have that much organic matter in the seabed, even near coastal bed.
No, never say this, because you have ignored the organic matter. See, the marine clays typically have, they can have anything up to 90% of the organic matter, and that's the reason. No wonder why the liquid limit is so high. Clear? So, I think you are mistaken. If you really want to understand a typical organic matter distribution in the clays, please read it on net, and particularly we have come across some clays where you have more than 80-90%. No, quantity of methane is something like, as long as the bacterial activity is there, it has to happen. The simple thing is, when you ferment something, most of the pickles, the way they have been formed, this is fermentation process, and that is how they give you a very different taste or tinge on your tongue when you put them. So, volumes are not an issue, because reservoirs of these deposits are enormous. Imagine, we are talking about the marine conditions. Okay, any other question? You have to create, when you do these type of tests, different types of pressure and temperature conditions in the laboratory. So, I am happy to say that my laboratory is the only one right now in the country, or maybe in Southeast Asia also. We do not have many such facilities where you can simulate and you can do testing of hydrates. So, this is how we are very unique, and very recently we have acquired this environmental traxial setup. We got it done ourselves, and where you can simulate the conditions of pressure and temperature, varied temperature pressure conditions, and you can see how the sediments are going to behave. And then later on, we like to find out their shear strength parameters and compressibility and the fluid flow and all these engineering properties. So, Bhini is working on creation or synthesis of the hydrates in the lab condition, and Lijit is working on the geomechanical stability of the sediments, which I will discuss subsequently. So, you follow the papers which have been written by Bhini Rani and Lijit Nambiar from the literature. We have published several papers, 2-3 papers. Now, it so happens that it is a very tricky, interesting subject. So, morphology of the hydrates would depend upon the different types of freezing processes. So, this is a subject which also deals with or interfaces with the frozen geomechanics. So, what I have shown over here is the morphology of the hydrates, which governs the geomechanical properties, can be understood like this. This is the skeleton of the particles, sediments, and if you look at the animation carefully, you will find that this is the pore filling. The crystallization of water takes place in the pores, and this is where the methane gets trapped. Now, these type of sediments are not going to be very good load bearing sediments. I hope you can understand, because the bridging between the particles is not so good, and the permeabilities are going to be extremely high as compared to the other situations which we call as load bearing. So, what has happened? I think you missed this animation, some of you. So, please do not write and see on the slides, that is going to help you. So, if I start from the pore filling, the further growth of the crystals is going to now be like this. That means, the particles are getting cemented, and hence the system is becoming load bearing. So, this system would have higher bearing as compared to the previous one. And further, what is going to happen is, if I say cementing process, all the particles get cemented and they become like cemented sands. So, these are the 3 mechanisms which people are trying to study, and these are the conceptual models. Remember, in conventional geomechanics, you talked about a rhombic structure and cubic structure, if you remember, is it not? This is how you visualize the entire granular material. Now, the same thing is being done over here with different mechanisms of the material and finding out the response at different environmental condition. Hope this point is clear. So, a big challenge is how to differentiate between pore filling, load bearing and cementing processes. And the way you talked in conventional geomechanics, the moisture content, here people talk about what is the gas content in the sediments once the hydrates are formed, alright. So, we call it as gas hydrate concentration, and the shear strength properties are going to be a function of gas hydrate gas hydrate concentration and the type of morphology which the system is exhibiting. It remains same as what you have studied in conventional geomechanics as Cardow structure, flocculent, dispersed and so on. Okay. It's easy said than done, it's very difficult to simulate these type of situations, and particularly I would like to see inside what is happening inside the cells, how the system is getting altered from one state to another state, and you can realize when you are working at such high pressures of let us say 30-35 MPa triaxial pressures, you can't look into the system because this is made up of a opaque steel, alright. But still people are trying to see inside, and where you have to learn a lot of biopsy. Now, look at this animation slightly carefully, and this is where I have talked about the extraction process, because after locating the places where the reservoirs are, ultimately you want to harness this energy, you want to tap this energy, you want to extract it from the ground, is it not, from the seabed, the way the petroleum is extracted. So, when you extract the methane gas, there are a lot of challenges, the gas is going to get dissociated from the crystal which you were talking about, Lavinder. So, the moment you bring it back to the normal standard temperature pressure conditions, the methane gas will liberate. It is what is known as dissociation. There is a lot of science and mechanics behind this which you should study, or you should attend the seminars by these guys. Ultimately what I want is, I want to produce energy. So, this is the hydrate, and the moment you expose it to the environment, it will catch fire and it produces heat. This is the whole purpose. So, most of the time these expeditions are created by government of India, alright, very expensive expeditions. The way there was a time when people used to go for Antarctica expeditions, you must have heard about. The scientists used to go there and they used to do a lot of stuff. Nowadays Mars, Moon expeditions are going on. They call it as a mission. I don't know what is the difference between mission and expedition. Climbing up on the mountains is expedition, is it not? So, this is how it happens. So, you know the place where the hydrate reservoirs are, you go in a ship and then lower down a casing. This is what is known as extraction well. How to design the extraction well itself is a big challenge. So, what Legit is trying to do is he is trying to simulate the whole process. I will tell you how. Now, once you start extracting something, first of all, extraction cannot be done as long as the system remains in the frozen state. So, what you have to do is, either you have to dissociate it, and for dissociation you have to do different types of techniques. So, extraction is by depressurization, release the pressure which the system has because of the natural conditions, and the natural conditions are because you have so much of water column, the depth of the sediments is this much. So, total height would be gamma water multiplied by this, total stresses, not height, total stresses would be gamma water multiplied by the water column plus gamma saturated multiplied by this much depth of the sediments. So, this much pressure are acting on the hydrate system, which has to be depressurized by allowing vacuum, so that the gas may come out. The second could be by thermal stimulation. Remember, the hydrates are at lower temperature. So, what you have to do is, you have to go drill the well, put heater wires and heat up the entire soil mass. Imagine. So, just now he was asking about the volumes. Now, I am giving you an idea that entire seabed is to be heated up, and once you heat it up, you are playing with the temperatures. So, either you play with the pressure or you play with the temperature, you can liberate the sediments. Now, what is happening is, once you are extracting something, I am sure you must have heard about the subsidence process in geotechnical engineering. So, the more and more water you extract from the wells or the aquifers, what happens? The entire system subsides, it settles. So, most of the cities are settling. Thailand is a good example. The more and more mining you do, the area is subsiding, alright. So, these are the challenges people are trying to handle these days. So, coming back to the point, when I do this depressurization or thermal stimulation, the chances are that what is going to happen, there will be a heat migration through multi-phase system, and this is how the entire thing gets liberated. So, the methane is catching fire and the water is coming out during the extraction process. So, there are coupled mechanisms which are associated with this. First is the heat migration into the system. Once you are heating the sediments, you have to study what happens to the sediments when they get heated up. So, later on in the course we will be talking about thermal properties of geomaterials. It is a big section which I will be discussing. I will be talking about electrical properties of the geomaterials, and that is the reason why we are discussing these type of topics in geomechanics, because live example is here. You have to heat the sediments to liberate the methane gas, and then only you can utilize it for your purpose. Remember one more interesting thing, now we are talking about multi-phase porous media, alright. So, we are not, the porous media is not devoid of microbial activities. In conventional geomechanics we never bothered about, we thought about only 3 phases: solids, liquid, gases. Microbial activity also comes, organic matter also comes in the play, and whatever fluid flow is taking place is a coupled phenomenon. That means, water and gas are travelling together through the porous system at environmental or sub-environmental temperatures and pressures. So, this becomes a complicated scheme. So, what is going to happen when you are extracting things? Water will come out, and I am sure you must have heard in your conventional geomechanics, whenever discharge takes place through the body of the dam, because of the critical gradients, what is going to happen? Quicksand condition of piping action will occur, clear. So, the more and more water comes out, what it does? It takes out all the fines along with it. So, this is what is known as washing out of the fines from the sediments. If the fines get washed out from a sediment, what is going to happen? The voids or the cavities will get created, and the chances are that the bearing capacity of the system is going to decrease. Hydraulic conductivity is going to increase, gas permeability is going to increase, and so on. So, look at the whole geomechanics is now changing. In the conventional geomechanics, you thought that everything is constant volume, inflow is equal to outflow, all the time you derived this, your control volume never deformed. Here we have all challenges. So, migration of fines causes loss of strength. So, all these problems are time and space dependent. Shear strength is a function of x, y, z and t, time. Cohesion is a function of x, y, z and t. Friction angle is a function of x, y, z and t. Hydraulic conductivity itself is a function of x, y, z and t depending upon the fluid, whether the gas phase you are talking about or whether the fluid phase, water phase you are talking about. So, this problem becomes very complicated, which people are trying to solve right now. So, these challenges lead to what? The first thing is the pipings and all whatever you have installed in the system, it gets unstable. So, well bore instability becomes a big issue. That means, the chances are that the well bore itself may become unstable, all the methane gas may bypass the extraction well, and then what is going to happen? It will get liberated into the environment, and if that happens, what is going to happen? Greenhouse gas. Are you realizing? So, this is a very intricate and sophisticated process. You do not want methane gas to enter into the atmosphere because of the extraction process. I am sure you must be getting an idea, these extraction wells are nothing but straws which you use for drinking the cold drinks from the cans or the bottles. So, the more and more you suck, alright, what happens? You are applying a negative pressure, inside the pressure was positive, high pressure, and then you depressurize it or you apply a bit of suction, then you can suck all the gases. So, this is something which people are trying to simulate in laboratory, including us. Now, when wellbore instability occurs, this is one issue. The second issue is seabed subsidence. I hope you saw this animation or not, you missed it. How many of you saw this? Good. That is what I say, there is no point in writing things, it should be all written in the mind, these are all the mechanics problems. So, look at this again. So, when you are taking out the fluids from this type of systems, what is going to happen? Concentrate here, seabed subsidence, alright. So, the collapse of the seabed takes place. Now, imagine whatever paraphernalia you have created on the seabed, because of this collapse is going to get destroyed. So, this could be a man made disaster. So, this is the subject which also deals with disasters associated with offshore systems. In case tsunami comes, the chances are that there could be a dislocation of the sediments and the methane gas may get liberated into the atmosphere. Earthquakes, what is going to happen? Because of the relative movement of the seabed, chances are that if you have reservoirs along the slip line, the gases will enter into the atmosphere, and that is what causes mid ocean fires. So, these are the issues, like if you have identified that these are the places where hydrates are, it is a good idea to extract them as soon as possible, because nowadays you have a lot of tsunamis affecting the system, you have earthquakes affecting the system, you have a lot of human activities affecting the system. You never know, tomorrow somebody might be putting a offshore pipeline, cross country pipeline for data communication. Most of your fiber optic cables are running on the seabeds. I do not know whether you are aware or not. Alright. So, how Andamans are connected with India, mainland India, read this whole story. So, these are the geotechnical engineering jobs which people are into. Now, if you want to learn more about the seabed subsidence and what it does, please read this PDF file where people are trying to simulate these type of conditions. Santa Marina is number 1 in this subject. So, read the papers written by him, and I wish some of you should get a chance to work with him in the Saudi Arabia. He has established his own lab. This is what is known as American University of Sharjah. So, mechanical and numerical modeling of gas hydrate bearing sediments, this is what Lijit is working on. Very intricate subjects, no doubt, but very satisfying and very you have to contemplate a lot to understand how things happen. Yeah, Femi, you have something to ask? No? Alright, any questions? So, you read this text, whatever is written over here, and you may get a feel of what is going on right now. So, I hope you realize that again THMC or TSCM is coming in the picture. These are hydrate bearing sediments and worth reading whenever you get time. Alright. Lijit has published a interesting literature review paper on geomechanical aspects of gas hydrates very recently, about 3-4 months back. Okay, so moving on to the discussion. When water flows out of the sediments, migration of fines occurs, loss of strength occurs, wellbore instability takes place, seabed subsidence occurs. Foundation instability occurs. So, the rigs which have been installed on the seabed are bound to collapse, and as I discussed, uncontrolled methane release is going to cause a greenhouse effect. Alright. How does the whole story appears to be? Srikant. I think I have exposed to a completely different realm of geomechanics today.
Yes, sir. It's interesting.
Yeah, it's very interesting, no doubt. But apart from interesting,
Worth learning.
yes, and quite intriguing. Very difficult to handle your samples at the conditions which prevail in the ocean beds. But I wish that people like you should be working and contributing in these areas, which are the most recent areas of geomechanics. Any questions? Yes, please.
The two methods of extraction is like you told, it is depressurization and thermal insulation. And how we'll find which is more suitable? What is the difference between?
Sorry. Well, you have no. This was me, not you. So yeah, it's a very good question. You are asking that how would you make sure whether depressurization works or thermal simulation works? Most of the pumps which are available in the market, they produce positive pressures or negative pressures.
Sorry, sir.
Most of the pumps which are available in the market, they produce positive pressures or negative pressures. Answer this question. If you can, then your first question is answered. So idea is how much suction you can apply. Imagine, simple thing what you do, you take a dropper and you press it and put it in the ink bottle and release the suction. What is the height of the water column which you get in the dropper ultimately? Say certain few centimeters. It's very difficult to make suction pumps. Very soon you will realize that negative pressures cannot be created by pumps. But look at the nature, it has produced different types of varieties of cactus which can survive in deserts also. How come? They can lift water up to a 220-meter deep also. See, this much pressure these plants can apply. So all the plants which are living in the arid regions, they can apply so much of suction on the soil to take out the moisture. Very interesting geomechanics subject. Hope you will realize. Ultimately, the entire thing is moisture migration through porous media or vapor migration through porous media. So depressurization is a difficult task. And where would you install these type of big pumps? On a boat or in a ship? And that too you are lifting it from a depth of 200, 250, 110 meters. Imagine, clear? So it's a big question. Number two, thermal, very easy to write on the piece of paper that do thermal destabilization. And just now I said what you have to do is you have to insert heater wires in the ground and you have to heat it. In the middle of the sea, how would you do all these things? How much area of the soil can be heated? So what is the conclusion? What is your answer? What is that you are going to recommend? So if you appoint a consultant who is an expert from Japan, who are already into the production stages, they will charge you what? Fortunes. India cannot afford. So what they have to do? Indians and developing nations, they have to develop their own technology. Nobody is going to help you. So this question is in everybody's mind, what should I do, A or B? Unfortunately, there is nobody to give you answer. As a nation, you have to decide what should be done. Do more R&D, and then people like you should answer after few months, years, that well, this is what is valid for KG basin, because there the type of soil is this, depth of water column is this, the pressure temperature conditions are these. Go to Andamans, the pressure conditions are different, types of soils are different. So one medicine cannot be used everywhere also. Are you getting the complexities and ideas? So this is a trade-off between A and B. I don't know which one is going to work. So in laboratory, we are still in a stage where I want to synthesize them first. Because imagine, another problem is if I have to bring out a sample by UDS from the seabed. First of all, it has to be a specialized UDS, where after taking out the sample also the pressure temperature conditions remain constant. Transporting them to the lab, then you should have a facility over here which again can assimilate the sample under those pressure temperature conditions. So these are very expensive experiments, and more than that, exploration itself is expensive. Find out the cost of each exploration which government of India has done until now. Alright, and this is the might of the nation. Nobody is going to help you. Why? They want to sell things. So if I have developed a technology, I like to sell it to you rather than help you out in developing a technology. Are you getting this idea? So it's a good question. Keep thinking like this. But then more than thinking, you have to work and you have to get a solution so that people can utilize it. Is this okay? So, yes please.
So if one has to simulate the
It's okay. Yeah, it's okay, fine.
if one has to simulate the conditions in the lab, how do it is in 200 meters. So how do we create that 200 meters?
I know the pressure conditions over there. I know the temperatures also. I can do different types of investigations. Try to read on this, what type of investigations are done to establish, offshore reconnaissance, to establish the thermal regime and pressure regime, and to establish what type of X-rays are done in the deep wells. I just gave you an idea about endoscopic cameras. You can load down the cameras and you can see what is happening in the intestine. So, you can see over here also. So, this interesting area is very intriguing. Is this okay?
While depressurization, will there be how we deal with that problem of cavitation? So
Cavitation of
that while pumping, the negative pressure may reach to
in the pipe or in the reservoir.
In the pipe.
Oh, that I can control, no. So, in your fluid mechanics course, you must have studied what causes cavitation. Total pressure head. So, that can be regulated. That is a pipe flow. But your question can be more complicated. Imagine this pipe is also a part of the frozen sediments. So, that is a very big challenge, that how fluid will pass through the frozen conditions of the steel casings and the pipes. So, there are a lot of people, mechanical engineers, who work in this area. They try to see what is the transmissibility of the gases through sub-ambient temperature conditions. I hope you are getting the point. Okay, check it out on net after you go to hostel today or tomorrow. Good. What message you are getting? Bigger picture, apart from environmental geomechanics course. Are you getting a message? What is the message you are getting? Anybody? First of all, the country is expecting you to give the answers to these questions, because there are not many geotechnical engineers in the world or the country. So, you are the people who are supposed to give these answers to the ministries. When your petroleum ministers ask a question in the parliament, what is happening to our program of hydrate modeling. So, they will ask, they will send you a question, parliamentary questions, tell what is happening. So, all this happens, we are a part of this. So, many times the subject does not remain in the books and the papers, it has to be delegated to the national activities as well. Alright, anything else? Sure? Okay. So, when you do extraction, there is a possibility of triggering tsunamis also. These are man-made tsunamis, geohazards, if you remember we were talking about. So, any type of collapse of bed might result into a wave form, creation of waves, and depending upon how much volume of the sediments is getting destabilized, that much would be the surges which you are going to create. Okay, sorry. Alright, so this type of expeditions have been taken up by Ministry of Petroleum and Natural Gas, Government of India. I hope you are aware of what is going on in the world these days, and there is a special directorate of Directorate General of Hydrates, hydrocarbons, which is known as DGH. Until now there have been 3 expeditions, NGHP 1, NGHP 2 and NGHP 3. This is what is known as National Gas Hydrate Program, and they are heavily dealing with the sample collection and on-board testing on the ships, and the regions which have been identified in Indian margins, we call that, is the KG basin, Mahanadi and Andaman basins, clear. And it is very interesting to see that the types of soils which you get are totally different. So, people who want to study the gas hydrates, Indians, they have beautiful natural laboratory waiting for them, and you just go and start your career in this. So, coming back to the point, we have been talking about energy geotechnics. I have taken you too much into the intricacies of the subject, and I have given you an idea about how these type of problems can be studied and sorted out under the realm of multi-phase geomechanics. So, you have to deal with a lot of chemical engineers, you have to deal with petroleum production scientists, reconnaissance guys, petrophysicists, government officials, definitely fluid flow, gas flow, condensation, cavitation, subsidence, mineralogy, biotechnology, because they are the guys who will be telling you what type of bacteria you have and what type of gases are going to come, whether it is feasible and useful to drill over here or not. So, if you are having more of pentane and butane and whatever, so this is of not much of use. I want to get mostly methane gas. Okay.
How deep the subsidence can be? Seabed subsidence, how deep can be?
I mean, it's a question I think I answered just now some time back, that it depends upon the thickness of the seabed. So, suppose if I ask you a question, how much the one dimensional consolidation would be in marine clays in Kerala? You construct a building, you remember the Cochin case next to the Lulu building. So, what happened? The entire building settled down, and then the first floor and the second floor, they were the part of the basements. So, this is a undeterministic process, depends upon so many parameters, mainly the thickness of the sediments and how unstable they may become. I hope you are aware of the fact that one dimensional consolidation theory of Terzaghi cannot predict very precisely how much marine clays get consolidated. I might show you some examples where I have seen 2 meter, 2.5 meter of settlement in the preloading stages. Right now, I am doing a lot of work for Indian Railways in the coastal region, and there the settlements are of this order. So, subsidence could be hundreds of meters. So, if hundreds of meters of subsidence is taking place, look at the height of the tsunamis which are going to create. That is the logic.
What about the effect on the marine life? Did they also study that thing? Like when you
Yeah, so I am sure ONGC, and there is something known as IEOT. There is a laboratory at Panvel. They talk about all these subjects. But we have to pick up our subjects, which is geotechnical, geophysical modeling and geotechnical modeling and all those things, rather than going into the details of the marine life and aquatic life, which is the job of maybe scientists who are dealing with fisheries and offshore environment.
So at the time of extraction, can we extract the methane directly from gas hydrates?
That is the whole idea, because you can't process it. So, just like many times what do you do? Aquifers or geysers, geysers, natural geysers. So, you just puncture over there and the water comes out. There is something like that. So, this is what actually we like to have. So, you just put a drill casing, destabilize the hydrates, regulate the flow by putting some valves and all, and then you get the direct gases. That is what is the production process is. And in the process you get the fresh water. So, you can fill up your mineral bottles in the offshore environment, imagine. So, two industries you can run together. In the offshore environment itself you are getting the fresh water, H2O, the molecular water. This is what we are planning at a landfill also, by the way. So, for me these situations are universal. They may exist in the offshore and they may exist in a landfill. So, in landfill also, if I just like open the bottle of a drink, what do you want to do? You want to take out all the fluids. So, for me the landfill is nothing but a container in which the entire thing is contained inside, and I would like to extract only one phase of the fluid. This is what is known as selective filtration of fluids. It is an interesting subject in chemical engineering which we are trying to learn as a geotechnical engineer. Why? The hydraulic conductivity of the water and the hydrocarbons and the gases is going to be different. So, I can regulate. So, for me the landfill becomes an industry, the ocean bed becomes an industry, and I will be able to take out only one phase, or otherwise I can have separators. You must have come across in chemical engineering courses. So, there is a mixed air contaminated, I want to separate out oxygen, carbon dioxide, nitrogen and so on. So, they use separators. See, present day science and technology is different. You can't be myopic that this is what I am studying. The first thing is you have to train your mind to think multidisciplinary. I hope you can realize, I give you so many examples, is it not? Suppose somebody comes to you for a consulting that in a basement of a mall, shopping mall, a beautiful problem which I was dealing with some time back. There are a lot of cars which are parked, and most of the time these cars engines remain on. Why? Because the drivers sit in AC room, AC cars, they do not put off their engines. So, what is getting emitted in the entire area? Imagine, and the whole thing is getting saturated with these fumes, and that is why they say in stationary cars you should not put on ACs, because CO is maximum. So, if you do not flush out all this into the atmosphere, what is going to happen? Now, why a geotechnical engineer is required to solve this problem? We will discuss this later on. Though this is the pollution of the air, but geotechnical engineering plays a very important role here. My materials can be utilized to solve different types of gases. Yes, please.
Sir, can you please explain that process which took place in that steel can, the extraction of gas hydrates when impedance and comes into picture?
Impedance.
Yeah.
Those are the tricks to see what is happening inside. So, that is the reason we will be talking about electrical properties of geomaterials in details, how electrical properties, thermal properties should be utilized to sense something, to see something, to visualize something, to feel something, to quantify something, clear? A process. Yeah.
Is it possible to protect the seabed, like when we take the methane, replace it with something such that
Very
the
good,
seabed-
excellent. So, that is what sequestration is. So, you do simultaneously two processes.
So is it possible?
Why not? So, there is one inflow, one exflow in the system, balance the two.
Bed